Hello, Keith Rucker here at VintageMachinery.org. Guys, today we are back to working on the Tally-Ho Capstan project, and today what I got to do is we got to make an adapter flange that's going to mount over here to the base. This is where we will be mounting the motor that will drive the winch to. So in previous episode, we had bored a hole in here that's the clearance for this the shaft to come up from the motor below. We put a bolt hole pattern in here, and the bolt hole pattern is to attach this flange that has to be made to fit down in there. So we're going to be making this out of a piece of cast iron. This is just a piece of Durabar that is going to basically just mount right up next to this. And anyway, we're going to get going. I've got a drawing over here of what we need to make, and I'll zoom in and show you that, and we'll get started getting this thing knocked out. So this is the drawing of the part we need to make, and this drawing was actually put together by Dave Webster up at Deep Blue Engineering up in the UK, and he kind of did the engineering work on this, and I'm going to be making a lot of the parts for it. He actually is sending me some parts that he made for it as well that hopefully will be arriving here soon to kind of help get this thing finished up. But this is the next item to be made. So basically, we've just got a chunk of cast iron here. It's a little over an inch thick total with the little piece up here. 7.677 inches in diameter or 195 millimeters. Again, guys, my shop, I work in inches. Not to say I can't work in millimeters, but my machines, everything in here is pretty much in inches. So I'm going to be working in inches. We'll be hitting the numbers for these metric numbers. And I know that probably aggravates some people, but just remember, inches is my native language. Millimeters is a foreign language to me, if you think about it like that. And while I can speak in that other language, my mind functions around inches because that's just what I'm used to. So that's what I'm going to work with, and that's just the way it is. Anyway, we're going to get our piece of metal over there tuned up. We're going to drill a hole in it, bore a hole in it. There's actually counterbores and stuff that has to be done with this. It has to have a mill slot slot milled at an angle in there, and then there's also has to be an arc cut out here for it to fit up in the area where it's going to go to. And see, that's just some pieces there. You can kind of see this is the base plate with the piece going down, and basically this is going to bolt right up under the bottom right here. And again, this is going to give us that little flange adapter that we need to be able to mount the motor and stuff too. So that kind of gives you an idea. I'll tell you what, let me show you the base so you can kind of get a better idea of how this is going to work. So you can see here's the hole that we drilled through. We got the bolt hole pattern, and we're missing one bolt up here, of course, where this stem is. And that's kind of the whole idea here. We have this piece cut out. That's going to actually kind of fit up in here, and have that cut out for it to fit up in here. And it's going to bolt down in here. The slot that we've got milled in here is basically for this little raised area right here. We're probably going to have to make some other... It's not really on the drawing per se, but we're going to probably have to make some other adjustments in here to kind of get this thing to bolt down properly. We're going to have to just kind of figure that out as we go. But we do have some kind of a starting point to kind of figure some of that out. So anyway, that's what we got to make, and we're going to get started. This is what we'll be making it out of. Again, a piece of cast iron Durabar. This is just an extruded cast iron product. Match the material that we're going to be going in. So this is, I think, 8 inches in diameter. It's probably a little bit oversized. Let's just kind of see what it is. So yeah, almost 8¼ inches in diameter. That needs to be 7.677 or 195 millimeters. So we need to get the outside of that turned down. Need to get the side of this faced. We need to get it cut to thickness. The total thickness that we're going to be needing is 1 inch plus a little piece that raises up on the one side here that's 3 millimeters or 0.188 inches, so 1.188, and we're starting out at about 1.3, so we need to get that thinned down. My thought here is, guys, is we're going to take this over to the lathe. We're going to face one side of this. I'm probably going to go ahead and flip it over, face the other side, and get it to the thickness that we need. And then I'm going to drill a hole right through the middle. And I've got an adapter on a flange, or an arbor rather, that we'll mount this to, and then we will turn the outside diameter to that hole. Once that is done, we'll probably chuck it back up on the outside again, and we will bore our holes on the inside to size, get that work done on the lathe. And then from there, it's over to the milling machine where we'll have to start cutting the slots, put the bolt hole pattern in, etc. So, and cut out that little chunk up here at the top, probably using the boring head. So a lot of work that's going to have to go into this. It's probably going to end up being a multi-video project, just because there's so much that's going to have to be done to this. So anyway, let's go to the lathe and we'll start our lathe operations and get this project going. I'm over here at the 16-inch Monarch lathe, and I've got my jaws turned around where I can grip them on the outside. There's basically just two bolts in here, and you can flip these around. Normally, for just doing round stock, you have it where you're gripping on this side, but I flip them around. Now I'm gripping on the inside of these, and it'll allow me to grab a hold of this kind of plate piece that we got. So I'm going to kind of take it over here, put it in here. We got to open that jaw up, it looks like. And that will seat up against the back there. Whoops. And allow us to grip that and turn it. And again, my first operation here is going to be to get a good face on this side. We'll flip it around, putting it up against those backs again. It'll be able to turn it again parallel, and that'll get the two faces parallel to one another. So let's get this thing faced off. All right, here we go. Just kind of touch off there. Yeah, kind of getting to the maximum diameter that I can handle on this. I'll take about 10 thou off of that. Just so you go right down through there. That's not going to be enough, but I'm going to go ahead and let it run all the way through there, then we'll take another pass. I slowed my RPMs down just a little bit for the second pass, just because that larger diameter. And that appears to be cutting all the way around, at least to start with. So we'll let it cut in and see if it goes all the way to the center. Looks like it's gonna feed up all the way to the middle, so that should have this side faced off. All right, we'll pull that out and we'll flip that part around. Good, we're gonna go ahead and flip this around now. So we'll pull this out, and we're just going to have to flip her right around here. Again, we'll put that up against the back jaws there, and we should be turning parallel to the other side. So let's go ahead and grip that down. The OD on this is running out, but that's an extruded product, so it's not perfect at all. So, all right, we're going to come in here and touch off again. And I'm going to feed in about 25 thou. It's actually about 30 thou. And we're going to let it go down and cut all the way down again. We got to take some thickness off of this side. So we'll go ahead and do this first pass to get a measurement, figure out where we need to go to. And we're going to take it down to thickness. All right. Let's figure out what our thickness is. Just going to use my calipers here to measure. We're at 1.295. And I'm just going to measure this in a couple of places around, make sure we're cutting parallel. And we're within a couple of thou. I think we're good. All right. Put that measurement in. 1.295. 1.295. I'm just putting that into my digital readout, and now I can kind of see where I'm going to. We're going to 1.118. I think I said 188 earlier, but it's 0.118. So we're just going to, 30 thousandths cut seemed to work pretty good. So we'll take about another 30 thousandths off of this, and we'll just whittle it down to size. Let's take another pass. Got some sparks going there, but not hurting anything. We'll just let it roll. As we go down on this diameter, the surface speed slows down a little bit as we're moving in. We'll bring you back here a little bit. It's going to take several passes on this thickness to get it to size. I'm taking 25, 30 thousandths per cut. We're at 1 inch 246 right now, and again going to 1.118. So we'll bring you back a little bit. All right, I took a little break here. I got it down pretty close to size, but it had a lot of heat in it, and I just wanted to let it cool down. Right now we're at 1 inch 135 thousandths, which is matching my digital readout. Again, we're going to 1.118. I've actually got a tolerance of 0.110 to 1.118, about an 8 thousandths tolerance according to my drawing. And anyway, we're going to go ahead, and I think I'm going to do is take a fairly light pass now that we've cleaned this up, or let it cool down, and we'll probably make another 1 or 2 passes, and after that, and hit the final number. That's the game plan. Let's get her done. We'll let it roll down through there, get another clean measurement after we've let that heat get out of it. Having that heat in there will make the part a little bit larger than what it is, so it'll probably be reading a little bit undersized here, but that's why I want to kind of sneak up on that last measurement. So, all right, we'll let this one go and get a good measurement, and then dial her into where we want to be. Let's get a clean measurement here. We're reading right on what my digital readout, 1.125. I'm going to check it in a couple places. Reading the same thing. All right, I'm just going to dial in my number. We're going to go to 1.118. And that's where we are on the digital readout, 1.118. This should be the final pass. All right, should be the size. Let me get my calipers out and check here. This should be, right, I'm reading 1.117, so we're 1 thousandths under right there. Let's see where we are here. That one's actually reading 118, and I've got a 8 thousandths tolerance, so yeah, we're fine. 2 of them measured 0.118. One of them measured 0.117. I could go down to 0.110, so I'm happy with my thickness. We're right on the money. So I think what we're going to do next is go ahead and bore a hole in here, drill a hole in here that we will then be able to mount this up on to turn the outside diameter. So let me get set up for that. All right, we are going to go ahead and drill a 1 inch hole in this part. And why 1 inch? I think the hole's got to be a little over 2 inches, but right now I just want to get a hole that we can pick this thing up on a arbor to turn the OD, the outside diameter, which I have one that has a 1-inch diameter, so that's what we're going for. We will start with a 3/8 inch hole through here, just to give us a pilot. Wow. Get some run out on that drill bit. This one's 13/16, just happens to be the next drill bit size. I had this one laid up on the lathe, so we're going with it. Guys, I see that run out. I'm not too worried about it. I just need a 1-inch hole through here right now that we're going to spin it on to define the outside diameter, and then we're going to be reboring this inside later on. So I just need a hole. If I was worried about it being true to that outside's got run out in it too. So if I was worried about it, I could bore it, but for what we're using it for, it's not going to matter. We'll slow the lathe down just a little bit for this last hole. This is a 1-inch. Yeah, and that gives us a hole we can mount the arbor on. All right, we're going to take this out of the lathe. I'm actually going to broach a keyway in this just because my my arbor that I'm going to mount it on has a key in it. And then we'll get this set back up on the lathe and turn the outside diameter. All right, we're going to put a 1/4-inch keyway in here. This is a 1-inch broach bushing. So we'll just drop that in. This is a 1/4-inch broach, size C, which fits that broach bushing. And we'll just run this down through there. Put a little oil on it.
Another.
This one requires 2 passes to get to the final depth, so we will put our shims in here and we will run it down a second time. There we go. That should do it. So to turn the outside diameter, we're going to put our arbor in over here, our mandrel, turning mandrel, and I have turned my jaws back around so that I'm not gripping on the outside, I'm gripping on the inside again. And I'm just going to use a 3-jaw chuck for this. We're going to put our mandrel in here. And somebody's going to say, well, that's not going to be running true. You should put it in the 4-jaw chuck. Well, yes, you're correct. It's going to have a little run out in it. But I'm going to be turning the outside diameter, and then I'm going to be boring the inside hole to match the OD. So right now, I'm not too worried if there's a little bit of run out in this. It's going to turn it round. It just may not be perfectly concentric to the hole in the center. But since we're going to be reestablishing that bored out hole, I'm not worried about it here. So the point there is, guys, is, pick your battles. I can go for perfection on everything. But if it's not going to matter, let's worry about getting our perfection on what matters. So, we got that up on there. Again, there's a key there to drive that. Now this mandrel is one that I made a long time ago for some job. I don't even remember what it was for, but I have used it many times since. It has come in handy, and I've just got a spacer. This is a milling machine arbor spacer. because it was made for something wider than this. No big deal. We'll put a live center down here in the end to give us some support, and now we can turn that outside diameter. Let's tighten that up. Let's bring our live center in here, and that should be supported. So now we can come in here and turn this outside diameter down to what we need. So I'm going to go ahead and we'll take about 100 thousandths on that first pass and get my micrometer out, and we'll start going for whatever that measurement is we need to hit. All right, let's see where we're at here. Got a 7 to 8 inch micrometer here. Should be it right there. We're at 925 plus 17 would be 942s. So 7 inches, 942 thousandths. I'm gonna put that in my digital readout. 7.942. And we are going to, what is it? 7.677. So I got a little bit to take off, so we'll just go ahead and keep working on taking that diameter down. Do another 100 thousandths. Pulling a nice chip off of there. We should be the size, and we got plenty of tolerance there, so this is not a super critical measurement by any means, but being a machinist, we treat them all that way. And we are at 677, which is right where we need to be. 677. All right. So with my outside diameter established, the next thing I want to do is we're going to actually be facing this face again. There is a little piece right in the center of this that's going to measure 2.952 diameter, and it's going to stick up 118 thousandths. So I wanted to go ahead and do this in the same operation because this face needs to be square to this face. The back side of this is not as critical, but this side here is. So I want to go ahead and while I've got it set up here, I want to go ahead and establish that. So we are going to just come in here, and we got to take 118 thousandths off the depth. We're going down again to, what is that, 2.952. I'm going to double check those measurements, and we'll go ahead and get this that little raised boss in there machined in. 2.965. Let's feed in. All right, so we're going to stop about right there. We'll come back out. Yeah, I did go in about another 25 thousandths on our depth here. Then we'll do another pass. All right, this should be the final pass on the thickness here. I'm going to have to work on the diameter once we get that established, but this should get us to the proper height of that boss. All right, here we go. I'm just going to kind of feed out there. And that should have that boss or the depth there. Like I said, we need to work on that diameter down there. Let me figure out where we're at, and we go from there. I'm using a depth micrometer here to check this boss, and my tolerance is 0.110 to 0.118. We're 0.116 right there. It is got a little bit of run out in it, but we're within tolerance here, so we're at 114. In all places around here, we are in that range that we need to be in. That's 113. .116. So I'm happy with that. 113. So now we need to get that diameter, and I did purposely make that a little oversized. So we're going to have to measure this with the calipers. And we're basically at 993 and a half, 994, and we're going to 952. So I'm going to put a different cutter in here, I think, to cut that, one that kind of reaches down in there a little bit better. And we're just going to work on getting that whittled down. Just going to depth by hand there, guys. And we will come in here and get another measurement. Yeah, really fuzzing it. All right, we're at 951. I was shooting for 952, but I got a 0.02 undersized tolerance, so I'm right in the sweet spot. So we are right where we need to be, right in the middle of that tolerance. And I think we've got this stuff all where we want it. I'm going to relieve the edge here on that just a little bit, and I think we'll be ready to flip this around and bore it out. All right, we have got our plate now mounted over in a 4-jaw independent jaw chuck. So each one of these jaws can be adjusted independently. And this is the face that we have the boss on, is in the back, so it's up against the jaws now. We're going to be working on the back side next. And now we need to make sure that we're running true. So I've got this in the 4-jaw chuck, and I've taken the time to indicate it in, and we've got less than half a thou run out on that outside diameter. So I am very happy with that. That is going to be just fine. And now what we need to do is get our hole bored on the inside, and I think there's a counter bore on this side as well that we need to do once we get down there to it. So let's get set up for doing some boring, and we'll get that hole put in there. All right, we got a boring bar in here that will fit up through that 1-inch slit, and it's going to come in here and touch off. And we're going to be machining out that keyway that we cut in along with everything else. So let's go ahead and just start boring it out. The nice thing about boring is that it's going to be running concentric with the outside diameter in this case. So a drill bit can get some run out in it, move around on you. With boring, you should be getting it true and square to the spindle on the machine. So we're going to go ahead and get this bored out. We got a ways to go. I'm going to go a couple of passes with this one. And as soon as I get that hole a little bit bigger, I'm going to go to a bit larger diameter, larger boring bar that will have less flex in it. I believe this one will fit in there. Yeah. You should always try to use the largest diameter or largest shank boring bar that you can, because it's going to be just more rigid as that gets larger in diameter. So we'll touch off again. Take another 100 thousandths pass. And I'm going to stop right here and get a measurement on that ID. As we get closer, we'll use a bore mic, but right now I'm just going to use my calipers. We're at 1 inch, 365 thousandths roughly. I'll put that in the digital readout. 1.365. And it should be right at 2 inches. I'm going to stop after this cut and again put a larger diameter boring bar in there. I've got a bigger one. I'll use it. So again, just going to a larger diameter boring bar, and also you want to get it, fairly close in. The less hangout you got and the larger diameter you got, the less flex that bar has in it, and the easier your turning's going to be. So we're going to come in here and touch off again. I'm going to do another 100 thousandths on the depth of cut. Yeah, and I'm going to stop here, get a bore micrometer, and we're going to get a good measurement on that bore now. Now let's get our bore mic up in here. And let's keep track of where we're at. All right, we're going to check this diameter now with a bore micrometer. So I'm going to start out, we're at 2 inches right there. And we're just going to count up here. So that's 25 thousandths, 50 thousandths, 75 thousandths, 100 thousandths, and so it looks like we're about 107 and a half, we'll just call it. So 2 inches, 107.5. I'm going to put that in my readout. And now we can go ahead and go to our 2.206 measurement. So I'm going to, as I get down in here, I've been making 100 thousandths passes. We're going to make probably, let's just do 20 thousandths passes. I'm going to do light passes as we get down there to it. Even with this big stout boring bar, there's going to be a certain amount of flex in there. So when you're making lighter passes, you're going to be making more accurate cuts. So we're going to go ahead and we'll just start up here. And I'm just going to dial in about 20 thousandths. So we're reading 2 inch 125 on the digital readout. And I'm going to make this cut, and then we'll come back and verify it again with the micrometer. Because it is a lighter cut than before, it's probably going to be off a little bit, but making these lighter passes, making a consistent 20 thousandths cut roughly each pass should get us a little closer to be more accurate as we get to those final measurements. And I can dial back in on the digital readout if I have to. I don't want to drag out on that because I don't want to mess that finish up in there. Let's see where we're at. So that's 200, 205.6. And they're on 207. We're right in the middle of the tolerance. And that's actually what I dialed in. I dialed in 207 because I did want to try to hit right in the middle, and we're right on the money. So there we go. I think we're good. All right, I think we're about ready to do the last step here on the lathe, and that is we need to do a counter bore on this bottom side here. Now, this drawing here kind of shows the finished part, and this is kind of complicated because we've got a groove up here that's going to be done on the mill machine, this groove is going to be done on the mill machine, and some other things going on. And this cross section is really confusing because it's got all these other components in here. So to simplify it, this is kind of where we're at right now. And basically I've got the outside diameter cut. We've got this little flange on the outside there done. The thickness is done. Everything's faced off. We got the whole board through the center. All we got left to do is this counter bore. Now that counter bore is 3.348 inches in diameter. I can go plus 0.02 minus 0 according to my tolerances that I have on my drawing. And the depth of that counter bore is 0.590 inches deep, which equates to 15 millimeters. And there was not a tolerance on that. So, I'm going to assume plus or minus 10, but we're going to go for much better than that if at all possible. So anyway, that is what we've got to do. And to do that, I'm just going to use a boring bar, and we'll get in there and get her knocked out. Let's do it. All right, so what I'm going to do is we're just going to come in here, and I'm just going to bump that cutter up to the surface there. And using my digital readout, I'm going to call that 0. That's going to give me my depth that we need to go. And again, that needs to be 590 thousandths of an inch deep, a little over half of an inch. This plate is 1 inch thick, at least in this part right here. So about half, a little over half of that. So, and then we will also need to do our diameter. I will establish the diameter once we start boring here. I think for right now, I'm going to bore down to a depth of a 1/2 inch. Once we get the diameter established, then we'll go in and we'll actually get the depth cut to final depth. I'm going to be a little bit short of it to start with. So let's get going here. So again, we got 0 on our touch off there, and I'm just verifying that on the digital readout. And I'm going to come in here and touch off in that direction. And then I'm just going to dial in 100 thousandths, and we're going to let her feed down, and I'm just going to watch my digital readout and stop at a 1/2 inch. All right, let's do it. 4, 6, 8, that's 100 thou on the depth. And here we go. I'm just going to, again, watch the depth on my digital readout. That's 100, 200, 300, 400, 500 thousandths right there. All right. All right, so we've ended up at about 349 and a half. It's supposed to be at 348. I got a 2 thousandths tolerance, so I am within my tolerance range. We're good to go right there. Now I need to get my depth done. And I need to get the bottom of this done now. So it needs to be at 590. So I'm going to go into 520 on my digital readout right there. And I'm just going to do this by hand. I'm just going to pull this out. See that diameter we wrap. All right, I'm just going to use my depth micrometer. We'll come across here and go down to the bottom. That's 523 on the depth. All right, let's just take it on down some more. Five, 85. Yeah, we're right on the money. 590 on the depth. Okay. I think we got our lathe work done. See, I want to deburr that. I'm just using a deburring tool on this inside. I've already deburred this outside out here. Feels good. We are done with the lathe work. All right, the lathe work I think we have done on the adapter flange, and I've got to do some looking here and do some measuring and so forth to kind of make sure I got everything exactly like it should be, but I feel pretty good about where we're at. May have to make this a little thinner. I've got to do some measurements. We may have to put it back in the lathe and face this side down right here to get it where it's going to be positioned just right, but we should be really close. I do still have quite a bit of work to do to this, but the rest of it's going to be done over on the milling machine. So basically, this flange is going to clamp down over here. It'll be centered up over this hole that we've got in here. We're going to have to put the bolt pattern in here to bolt it down. We're going to have to actually cut a slot out up here so that this will fit up against this piece that's coming up through the middle. We got to make room for it to slide up in there. And we're going to have to do some milling on the bottom of this to kind of make it all made up into this. I don't think it's going to be touching in every place, but we do need to do some milling to kind of make it fit a little bit better than what it's going to just out of the slot. So the milling will be coming up later in a separate video, but we've got the basic outside diameter of this thing like it needs to be, and happy to get that part done. So more to come, but we're done with the lathe work on this adapter flange. So there we go, progress made on the Tally-Ho Capstan project, and like I said, we'll be continuing on with this coming up soon, and some more videos forthcoming to get this thing knocked out. Well, with that, guys, I think that's going to be a wrap. As always, thanks so much for watching. Please do subscribe to the channel if you haven't already. Those thumbs up and comments are greatly appreciated. It really helps out with the algorithms on YouTube. And big, huge thank you, as always, to the people who support the site financially through Patreon, PayPal, etc., as well as all those who have subscribed already. Thank you very much. We appreciate your support. And with that, guys, we'll catch you on the next video again. Thanks for watching.